이노벤스는 리튬 배터리 지능형 제조 기술을 기반으로 이번 서울 코엑스에서 열리는 인터배터리 2026에 참가하였습니다.
Hi everyone, I'm Leo from Inovance Korea Technical Team. Let me introduce the Z-Tap staking machine. The Z-Tap staking process cuts positive and negative electrode materials into small pieces. This machine separates these positive and negative electrodes with a separator, then stacks individual electrodes alternately in sequence to form a single large seal. Next, I will introduce the main advantages of this machine. The first one is the parameter adaptive algorithm that reduces equipment commissioning time. The second one is the separator and the electrodes adopt a soft start and a soft stop, which reduce tension fluctuation during acceleration and deceleration period, improving the seal quality. Intermittent die cutting machine. This machine includes winding, unwinding, and swing arm synchronization functions. This equipment incorporates algorithms for tension control, roll diameter calculation, cam tracking, shearing, and so on. These algorithms are used in the lithium battery industry for cylindrical battery winding and coating machine unwinding. In addition, they are widely used in the packaging and printing industries. Next, I will introduce our Air industrial wireless communication technology. The world's first full-stack industrial wireless communication technology independently developed by Inovance. Supporting high-precision synchronized motion control, it's the only industrial wireless communication solution globally that supports the EasyCat protocol. It features 1 millisecond communication cycle and 1 microsecond jitter. It has industrial-grade anti-interference capability and reliability of up to 6 nines. It's easy to deploy and offers flexible networking. Cable line workload is reduced by 50% and equipment failure rate is reduced by 80%. In the lithium battery industry, it's mainly used in battery module and battery pack assembly line. Finally, I'd like to introduce our laser marking robot. First, after receiving a command, the robot moves to the nameplate box. The vision system captures the nameplate and detects its quality. Then the robot picks up the nameplate and moves it under the laser. The robot and the laser communicate via Modbus. After the process, the robotic tool, which is driven by a cylinder, moves the nameplate to the unloading point and sets it down.